Hi everyone, and thank you for joining. We'll continue now with question number 28E on page 113. So question 28E on page 113 states that we have the function y equals 2x minus 5 to the power of 3 over x plus 8 to the power of 2, and we want to differentiate it. Now remember that we want to write the answer in factored and most simplified form. And as you can see here, we have the ratio or the rational function, the ratio of two functions. And that means that we will have to use the quotient rule. So the quotient rule in differentiation states that the derivative of f over g prime would equal, so the way we like to write this is we know we're going to have a fraction, because fractions usually produce other fractions. And the denominator will have g to the power of 2. Now the numerator will have something similar to the product rule, so fg and gf, and we'll differentiate f and g respectively in each group of terms. But unlike in product rule, here we have the difference between the two terms. So we are applying this formula to our function, and we're going to say that dy dx is equal to big fraction. So remember that we are taking the derivative of f. This will be our f. So we'll write the derivative of f, and f is 2x squared minus 5 to the power of 3 multiplied by the denominator, which is our function g here, x plus 8 squared. And then we have minus, sorry, here we go. And we have minus the derivative of the denominator. So we are taking the derivative of x plus 8 squared. And we are multiplying it obviously by the numerator again. So 2x squared minus 5 to the power of 3. And it seems that we need a bigger fraction line here. All right, now it's perfect. And the next thing we want to do is bring this denominator, which is to the power of 2, to another power of 2. And voila, now we have to differentiate. So what we just did was write out the quotient rule for our function. Now, in the next step, we're differentiating, and the derivative, as you can see, of this expression here, we have a chain, and let's take a look at this chain. I'm going to make this a little bit less pronounced. Here we go. So we have a chain, so we have a power of 3 out, so that will be 3, and then power of 2. And then inside doesn't change, 2x squared minus 5. And then, as you can see, because this represents another function on its own, so the change of this one will affect how fast this entire thing is changing. And that's why we call it chain rule, because these two functions are chained or connected to each other. It's a composite function. So derivative of 2x squared is 4x, just power rule. Derivative of negative 5 is 0, so just 4x in here. And then we have x plus 8 to the power of 2. Now, next, we continue with the next chunk of terms here. Again, a similar idea as in the previous chunk of terms. So we have to differentiate a composite function. So we are going to deal with the outside function first. So we have number 2 that becomes from exponent into coefficient, and the power of 2 reduces by 1, and we don't really have to write number 1. I'm just formally writing it for now. And then x plus 8 doesn't change inside. And as you can see in here, inside we have another function, and the rate of change of this function is actually equal to derivative of x, 1. When you multiply by 1, the expression doesn't really change, but we'll formally write it just to show that we have taken care of the derivative of the composite. And then we multiply by the last factor, which is 2x squared minus 5 to the power of 3. Oops, running out of room here. So next we multiply or divide here by x plus 8 to the power of 4. So what I meant was multiply the powers here. So let's continue with cleaning up the expression a little bit. So we're going to make the fraction line all the way to the end. And as you can see here, we have a monomial 3, monomial 4x. Together they make 12x. And then 2x squared minus 5 to the power of 2, x plus 8 to the power of 2, and then minus. Now 2 times 1 equals 2, so we're going to leave it as 2. We have x plus 8, and then 2x squared minus 5 to the power of 3 divided by x squared plus 8 to the power of 4. Now let's check and see what we can factor. Long line again. So we're inspecting the monomials first. 12x and negative 2 have 2 as a common factor. Now, next we look at 2x squared minus 5, which appears in both chunks of terms, right? So the chunks of terms, or what we're calling chunks of terms, are separated by a minus or a plus sometimes, but here we have a minus. So as you can see, 2x squared minus 5 have powers 2 and 3 in each group of terms here. So that means 2x squared minus 5 is common, and we take out the smallest power, which in this case is 2, and then x plus 8 is common. Here's power 2, here's power 1, so smallest power, or power 1, comes out. And open square brackets, and we're going to write whatever is left over from each group of terms. So from 12x, take away 2, we get 6x. From 2x squared minus 5 squared, we have the entire thing out, so nothing left in. And x plus 8 squared, x plus 8 is out, so x plus 8 power 1 is in. And then we have minus, so 2 is all out. X plus 8 is all out. 2x minus 5 to the power of 2 is out, so here we have power 3, so 1 power is left inside. So we'll write 2x minus 5. Now be very careful, because especially in subtraction, like quotient rule, whenever we are subtracting a binomial, we need to keep that in brackets. It's a very easy mistake to make, but we won't make this mistake, obviously. Because we practice enough, right? And then we have, oops, you can see my next question here, so I'm going to hide it. Just kidding. Here we go. We have a big fraction line, and we are going to rewrite this first factor the way it is. Nothing changes. And for things that don't change, you can write them fast, save time on a test. And the things that need a little bit more, attention, and you need time to calculate, so always go slow and steady. So 6x squared times x, we have 6x times x, 6x squared. And then plus 48x, and then minus 2x, and then plus 5. Close the brackets, and x squared plus 8 power 4. And I think we have arrived almost to the end. So we have dy dx equals, and long line, and we have 2x minus 5 squared, and then we have x plus 8, and here we have only 2 terms that we can simplify and we can bring together. They're like terms. 6x squared plus 46x plus 5, close brackets, x squared plus 8 power 4, and voila, this would be the answer. And I hope that this made sense again, and I hope you found the instructions useful. And bye for now. Have a wonderful day.